In the Amazon, death does not always arrive with blood. Sometimes it arrives quietly, through pressure, water, coils, jaws, or a hold placed exactly where breathing begins to fail. A prey animal can still be alive, still conscious, still fighting, but once air is taken away, every second becomes smaller. The rainforest has many ways to make breathing impossible. Some killers crush the chest. Some drag prey below the surface. Some lock the throat. Some turn panic itself into the final mistake. This episode is about the Amazon predators that do not need to destroy the whole body first. They only need to take away air. The flooded forest does not announce danger the way open ground does. It hides it inside reflections, inside floating leaves, inside water that looks still only because everything beneath it has learned patience. In the Amazon wet season, the forest floor disappears under brown-green water, and the trees seem to grow straight out of the river itself. Roots twist below the surface like drowned fingers. Fallen branches collect drifting plants. Small fish move through the shadows where insects once walked. Birds call overhead, monkeys test the canopy roots, and somewhere in that quiet, heavy world, an anaconda can wait so perfectly that it becomes less like an animal and more like part of the flood. That is the first truth about the anaconda. Its power begins before the strike. It is not built like a chase predator that must run down prey across open space. It is built for closeness, concealment, and one violent correction of distance. The eyes and nostrils sit high on the head, allowing the snake to rest almost completely submerged while still watching and breathing. The body can vanish under dark water, mud, vegetation, and glare, leaving only a barely readable shape at the surface. To prey animals coming to drink, cross, feed, or rest near the edge, the danger is not obvious because it is not moving. And that is exactly the point. In a forest where energy is expensive and opportunities can vanish fast, stillness is not laziness. It is strategy. When the strike comes, it is not the long dramatic pursuit people imagine. It is a short-distance ambush powered by stored muscle. The head shoots forward, the jaws seize, and the backward curving teeth act less like knives and more like gripping hooks. They are not designed to chew. They are designed to prevent the first mistake from becoming reversible. A mammal, bird, reptile, or caiman that is caught at the edge of the water has only a tiny window to break contact. If it fails, the anaconda's body begins solving the rest of the problem. Coil after coil moves into position, not randomly, but with brutal efficiency, wrapping where leverage matters most. Around the chest, around the shoulders, around the body's ability to expand. The prey is still alive, still fighting, often still incredibly strong. But the fight has moved into a new kind of physics, and strength is now trapped inside a tightening circle. The old idea was that constrictors kill by crushing bones, but the more accurate truth is worse in a quieter way. The main weapon is pressure against circulation and breathing. As the prey exhales, the coils tighten slightly, taking away that space. When the animal tries to inhale again, the ribs and lungs meet a wall of muscle. Each breath becomes smaller. At the same time, pressure can interfere with blood flow, making the body lose function faster than simple suffocation alone would suggest. The anaconda does not need to be angry, fast, or dramatic. It only needs to keep the body from resetting itself. Every second the coil holds, the prey's own biology starts working against it. Panic burns oxygen. Struggle drains energy. The chest cannot open properly. The heart is under pressure. The animal is not just being held, It is being forced into a shrinking internal world. Water makes the whole scene more unforgiving. On land, a trapped animal might brace a foot, twist against the ground, or slam its body into vegetation with some hope of creating leverage. In flooded forest or swampy channels, footing fails. Mud gives way. The surface breaks and closes. A hoof, claw, or paw that should push against earth finds only silt and slipping roots. The anaconda, meanwhile, is at home in this unstable place. Its body is heavy, muscular, and perfectly suited to using water as cover and support. A large green anaconda can be one of the heaviest snakes on Earth, and that weight matters. In water, mass becomes less clumsy and more useful. The snake can anchor, roll, pull downward, and let the environment help remove the prey's options. The river does not have to be deep to become a trap. It only has to be deep enough to steal balance. This is why an anaconda attack feels so different from the visible violence of teeth and claws. There is no need for repeated biting, no chase across the forest, no loud display after the first moment. The horror is mechanical and intimate. The prey may still kick, splash, twist, or slam its body against the bank, but the important battle is happening in the ribcage. The anaconda is not trying to win a wrestling match in the human sense. It is waiting for the prey's body to run out of usable breath, usable circulation, and usable coordination. That patience is one of its most dangerous adaptations. A predator that can afford to wait does not need to panic with its victim. The snake's own body is a masterpiece of this lifestyle. Its muscles are arranged in long, powerful bands that allow it to grip, bend, tighten, and hold with extraordinary control. Its ribs extend through much of the body, giving structure to a living cable of pressure. Its skin can stretch during feeding, and its jaws are connected by flexible ligaments that allow the mouth to move around prey far larger than the head suggests. Even feeding is not a casual act. After a successful kill, the anaconda must swallow whole, slowly working the prey inward with alternating jaw movements. A large meal can take days or weeks to digest, depending on temperature and size, and during that time, the snake becomes more vulnerable and less mobile. That detail matters because it reminds us that even the top ambush predator is making a gamble. One enormous meal can fuel it for a long time, but catching, subduing, swallowing, and digesting that meal all carry risk. Temperature shapes that gamble too. Like other reptiles, anacondas depend heavily on external warmth to regulate body function. Digestion, movement, and recovery all respond to environmental conditions. In the Amazon, a snake that has eaten may seek warmth in shallow water, sunlit edges, or open patches where heat can help the body process the meal. This is not just background biology. It is part of the predator's rhythm. The anaconda's life is tied to water levels, seasonal flooding, prey movement, and available heat. When the floodplain expands, hunting space expands with it. When waters shrink, animals concentrate near remaining channels and pools, and the edges become more dangerous. The snake is not separate from the ecosystem. It is one of the reasons the water's edge has rules, and those rules affect many animals at once. Capybaras graze near rivers because water offers escape from jaguars and other land predators, but that same refuge can hide an anaconda. Birds feed along flooded branches because insects and fish are abundant, but low perches can become ambush points. Young caimans are predators themselves, yet even they can become prey to a large enough snake. The Amazon is full of these reversals. A safe route from one danger can become the entrance to another. That is what makes the anaconda more than a giant snake in a dramatic scene. It is a pressure point in the food web, a predator that forces other animals to measure distance, footing, water depth, and silence. The cleanest nightmare is not that the anaconda is unstoppable, it is that its method is so simple once it works. One hidden body, one accurate strike. One coil placed where breathing matters. After that, the forest does not need to become louder. It can stay exactly as it was. Insects buzzing, leaves dripping, sunlight breaking across dark water, the surface settling back into place. The anaconda survives because it understands a brutal truth of the flooded Amazon. You do not always need to tear prey apart to defeat it. Sometimes you only need to take away the next breath. The boa constrictor belongs to the quieter architecture of the Amazon. It is not the giant shadow of the flooded channels, and it does not need the open water to turn panic against its prey. Its world is closer, tighter, more crowded. It lives among buttress roots, low branches, vine tangles, fallen logs, leaf litter, and shaded forest edges where distance disappears quickly. In this kind of habitat, an animal does not always see danger approaching from far away. A lizard slips along a root, a rat moves through dead leaves, a bird drops too low between branches. The forest is thick enough to hide mistakes, and the boa is built to wait inside those mistakes. A boa constrictor's camouflage is not just a color pattern, it is a survival system. The reddish-brown saddles, tan body, dark markings, and broken outlines help the snake dissolve into bark, dry leaves, shadow, and filtered sunlight. In the Amazon, where the ground is never visually simple, that broken pattern matters. The forest floor is a mess of dead leaves, seed pods, roots, fungus, insects, and moving light. A smooth, single-colored animal would stand out. The boa does the opposite. Its body interrupts itself. It becomes patches, curves, and shadows. To a prey animal scanning for clear danger, the snake may not register as one continuous predator until the distance is already gone. The first bite is fast, but it is not the true killing tool. It is the anchor. The boa's teeth curve backward, designed to hold rather than slice. Once they catch feathers, fur, or scales, the prey is pulled into the real trap, the body. The coils do not arrive like random rope thrown in panic. They organize. They loop around the prey with control, adjusting as the victim kicks and twists. That is where the fight changes from injury into containment. The prey is no longer simply trying to escape a mouth. It is trying to escape an entire muscular system wrapped around its ability to move, breathe, and circulate blood. The old explanation was simple. Constrictors suffocate their prey. That is partly true in the way a closed door is partly about wood. The deeper reality is more precise. Constriction puts pressure on the chest, making breathing harder, but it can also interfere with blood circulation. The heart struggles to push blood through compressed vessels. Blood pressure changes. Oxygen delivery fails. The brain and muscles begin losing the fuel they need to keep fighting. This is why constriction can work faster than a slow, dramatic suffocation scene would suggest. The boa is not just squeezing air out of the lungs, it is disrupting the internal transport system that keeps the body alive. That makes the boa's method strangely intimate. A clawed predator attacks from the outside. A venomous predator injects chemistry into the body. The boa attacks a basic rhythm the prey cannot refuse. Every animal must breathe. Every heart must move blood. Every burst of struggle demands oxygen. The harder the prey fights, the more urgent those needs become. and the tighter the trap feels. A rodent may claw, bite, and twist. A bird may beat its wings against leaves and bark. But inside the coil, movement becomes expensive. The boa does not need to match every motion with rage. It only needs to hold long enough for the prey's own biology to collapse under pressure. One of the most remarkable details about constrictors is their sensitivity during the kill. Studies on boas have shown that they can respond to the heartbeat of prey, adjusting how long they hold depending on whether the heartbeat continues. That fact changes the way we should understand the animal. This is not a mindless rope of muscle. It is a predator reading the body it has captured through pressure, vibration, and contact. The coil becomes a sensory instrument. The snake can feel the fading struggle, the weakening pulse, the shift from resistance to stillness. In the darkness under roots, the boa is not guessing. It is listening with its body. The forest gives this hunting style real advantages. A boa does not need a long runway or a clean angle. It can hunt from a branch, from a hollow, from the base of a tree, or from the edge of a trail used by small mammals at night. Younger boas are often more comfortable above the ground, using branches and vegetation as hunting platforms. Larger adults become heavier and spend more time on the ground, where their size turns roots and fallen logs into cover. That shift is important. It means the boa's life changes with its body. The young snake climbs through a three-dimensional world of branches and bird nests. The older snake becomes a heavier forest floor ambusher, targeting animals that move through low cover and shadow. Its senses fit that world. The forked tongue samples chemical traces from the air and ground, delivering information to the Jacobson's organ in the roof of the mouth. To us, a patch of leaf litter may look empty. To the boa, it can carry the chemical memory of a rodent route, a lizard crossing, or a bird roost nearby. The snake also reads vibration and movement. A small animal rustling through dry leaves is not just making sound, it is sending signals through the ground and vegetation. At night, when the forest becomes cooler and many mammals become active, these senses help the boa turn darkness into an advantage. But the boa is not invincible, and that matters. Large birds of prey, jaguars, caimans, and even humans can threaten it. Young boas are especially vulnerable, which is why concealment matters from the beginning of life. They must survive long enough to become powerful. Even feeding carries risk. Swallowing prey whole is slow work, and after a large meal, the snake becomes heavy and less ready to escape. Digestion itself is an intense biological event. The boa's metabolism rises dramatically as its body breaks down bone, muscle, fur, feathers, and organs. A meal is not simply stored. It transforms the snake from a patient hunter into a living furnace of digestion. Thermoregulation shapes this process. As a reptile, the boa depends on external heat to manage body temperature. In a rainforest, that does not always mean lying exposed under brutal sun. It may mean choosing a warm patch near a forest gap, resting against heat-holding ground, or shifting between shade and filtered light. Temperature affects digestion, movement, and recovery. Too cool, and the snake's body slows. Too exposed, and it risks overheating or being noticed. So even after the kill, survival remains a negotiation with the environment. The boa's power is physical, but its success depends on timing, temperature, concealment, and patience. Ecologically, the boa is one of the forest's quiet regulators. By hunting rodents, birds, lizards, and other small to medium animals, it helps shape the movement and behavior of prey populations. Its presence changes how animals use the forest. A branch is not just a branch if a boa can wait above it. A root tunnel is not just shelter if a coil can fill it. In this way, the boa adds invisible pressure to the ecosystem. Prey animals survive by becoming more alert, more cautious, more selective about routes and resting places. The forest becomes smarter because predators punish carelessness. What makes the boa constrictor frightening is not speed or size alone. It is the calm precision of the trap. The bite says, "Stay here." The coils say, "Spend your strength." The pressure says, "Every breath now belongs to me." In dense Amazon cover, where leaves hide movement and shadows break every outline, that is enough. The boa does not need to dominate the whole river or announce itself like a monster. It only needs one branch, one root, one passing animal, and one perfect moment where the forest closes around the lungs. At the edge of an Amazon river, the most dangerous line is not where land ends and water begins. It is the few inches between a lowered head and the surface. Animals come to that line because they have to. Capybaras drink there. Birds pick through floating plants. Monkeys descend toward overhanging branches. Deer, peccaries, lizards, and even other predators use the banks because rivers are not barriers in the rainforest. They are roads, watering places, hunting corridors, and escape routes. But the same water that keeps the forest alive also hides one of its oldest ambush designs. A caiman can sit beneath floating leaves, mud glare, and broken reflections until it is almost not an animal anymore, just another dark shape inside the river's skin. The caiman's attack begins with patience. Its eyes and nostrils sit high on the skull, letting almost the entire body remain underwater while it watches the bank. This is not a small detail. It means the caiman can breathe, see, and wait while exposing only the minimum amount of itself. The armored body, tail, and limbs stay hidden below, where brown water erases size and distance. From above, the river may look empty except for bubbles, drifting seeds, and the occasional ripple. Underneath, the caiman is already lined up like a submerged spring. The prey may believe it is choosing a safe place to drink. The caiman has already chosen the angle. When it strikes, the bite is only the first part of the sentence. The jaws close with a grip built for holding, not chewing. The teeth are conical and interlocking, designed to puncture and pin slippery prey rather than slice neat pieces away. A fish, bird, mammal, or reptile caught in that clamp suddenly has a bigger problem than pain. Its body is now connected to the water through the predator. On land, a victim might dig its feet in, pull backward, or twist against solid ground. At the river edge, the surface breaks, mud gives way, and balance disappears. The caiman does not need to finish everything instantly. It only needs to move the struggle to a place where the prey's lungs become useless. That is the real suffocation mechanism here. The caiman does not wrap the chest like a snake. It controls geography. It controls the location of the head, the direction of the body, and the distance between the nostrils and air. Once the prey is pulled under, panic becomes part of the predator's toolkit. Kicking wastes oxygen. Thrashing clouds the water with mud. Splashing hides clear orientation. A trapped animal may still be powerful, but strength means less when every movement happens in a medium the caiman understands better. The river itself becomes muscle, current, silt, floating plants, submerged roots, and the predator's body weight all help turn a single bite into a drowning trap. The caiman's body is made for this kind of control. Its tail is not just for swimming, it is the engine that turns stillness into explosive movement. A sudden sweep can launch the animal forward or drag prey sideways before the victim understands what has happened. The limbs are short and strong, useful for pushing through shallows and bracing against the bottom. But the tail does most of the real work in water. The skull is low and heavy, shaped for ambush from below. Even the eyes are protected by a transparent nictitating membrane, allowing the caiman to see underwater while shielding them from debris and impact. This is a predator designed around the exact moment when air and water change places. There is also a brutal calm in how caimans handle resistance. If prey is too large to swallow whole or too difficult to control, the caiman can twist its body in the water, using a rolling motion that turns the river into leverage. This famous rotation is often associated with crocodilians tearing off pieces of food, but before that, it can also disorient and exhaust prey. The victim loses direction. The surface becomes harder to find. The body is rolled through mud and bubbles while the jaws remain locked. It is not dramatic in the way people imagine a battle. It is worse because it is practical. The caiman is not trying to look violent. It is using physics. Its sensors make the ambush even more refined. Crocodilians have pressure-sensitive organs around the jaws that can detect tiny disturbances in water. To a caiman resting in darkness, a struggling fish, a bird touching the surface, or a mammal stepping into the shallows can create information before it becomes visible. The river is full of noise, but the caiman is built to read the right kind of noise. At night, this advantage becomes even stronger. The eyes reflect light, the body vanishes, and the bank becomes a place where prey animals must choose between thirst and risk. The Amazon does not give free water. Everything that drinks pays attention, or pays differently. Caimans are also more than shoreline killers. They are part of the river's structure. Smaller caimans take fish, insects, crustaceans, amphibians, and small vertebrates, while larger species, especially the black caiman, can take much bigger prey. This creates pressure across many levels of the food web. Fish behavior changes in waters where caimans hunt. Birds choose perches with more care. Mammals approach banks with hesitation. Even predators must respect the edge. A jaguar may hunt caimans in some places, but the relationship is not simple dominance. In the Amazon, hunter and hunted can switch roles depending on size, location, depth, darkness, and timing. That is what makes the ecosystem feel alive rather than neatly ranked. The caiman's cold-blooded biology also shapes its rhythm. As a reptile, it depends on external heat to regulate body temperature. It may bask on banks, logs, or exposed mud to warm itself, then slip back into water to hunt, cool down, or hide. Warmth affects digestion, muscle performance, and recovery. After feeding, a caiman may need heat to process the meal efficiently, turning sunlight into digestive power. This makes the animal part of a daily exchange between river and sky. It hunts from water, rests on land, warms in light, and disappears again when conditions favor patience. The predator's violence is sudden, but its life is built around careful energy management. One of the more surprising truths is that caimans are not just mindless ambush machines. Many crocodilians show parental care, and female caimans can guard nests and young. Hatchlings called from inside eggs or soon after emerging, and the mother may help protect them during their most vulnerable period. That tenderness does not soften the animal's role. It makes it more complete. The same jaws that can drag prey under can also carry young with astonishing care. Nature does not care if that feels contradictory. The river does not divide animals into monsters and parents. It builds whatever works. The horror of the caiman comes from how ordinary the scene looks before it happens. A muddy bank, a warm current, a floating mat of vegetation, a thirsty animal leaning down for one clean breath before drinking. Then the surface breaks, and the entire map changes. Land is no longer safe because the body is being pulled away from it. Water is no longer escape because the predator owns it. Air is no longer guaranteed because the head is no longer where it needs to be. The caiman's true weapon is not just bite force, it is placement. It understands that life depends on access to the surface, and once it takes that access away, the river finishes what the jaws began. The giant otter changes the feeling of suffocation because it does not wait like a submerged reptile or tighten like a snake. It moves, it thinks in motion. It brings noise, speed, teeth, teamwork, and pressure into a river that already hides too much. In the blackwater channels of the Amazon, where the surface reflects the forest like dark glass, a giant otter can cut through the water with a confidence that makes other animals look suddenly clumsy. Its body is long, muscular, and built like a living spear, with webbed feet, a powerful tail, and a neck thick enough to drive the head forward when the bite lands. This is not the silent trap of the caiman. This is active control, and in water, control is often the difference between one breath and no breath. The giant otter belongs to the river in a way few mammals do. Its dense fur traps air close to the skin, helping insulate it during long hunts, and that coat is so valuable that humans nearly erased the species for it. The whiskers around its muzzle are not just decoration. They are sensitive tools that help detect movement in cloudy water where vision can become unreliable. Its eyes and ears are adapted for swimming, and its body can twist with astonishing agility as it chases fish through roots, submerged branches, and floating vegetation. A fish trying to flee into cover is not escaping into emptiness. It is entering a maze the otter knows from inside. Most of the time, giant otters hunt fish, especially species that move through the river margins, oxbow lakes, and flooded forest edges. But the important thing is how they hunt. They do not simply bite whatever passes nearby. They pursue, corner, flush, and coordinate. A family group can spread through the water like a moving net, each animal responding to the others with sharp calls, body position, and sudden turns. The river becomes noisy with splashes and whistles, and that sound is part of what makes the giant otter so different from the colder predators in this title. There is no illusion of stillness. The attack is alive, social, and intelligent. For prey, that social pressure matters. A single predator is one problem. A group is geometry. One otter pushes from below, another cuts across the side, another blocks the route toward open water. Fish that rely on bursts of speed can suddenly find their escape angles closing. A smaller caiman, a turtle, or another aquatic animal that becomes the target may face not only teeth, but repeated harassment, rolling, grabbing, and repositioning. In water, this kind of pressure can become dangerous fast. The victim may not be killed by one clean wound. It may be forced into exhaustion, disorientation, and failed access to the surface. The fight becomes less about one bite and more about whether the animal can recover its breathing rhythm before the next attack breaks it again. That is the key to the giant otter's version of suffocation. It is not always direct drowning in a simple sense. It is surface denial. An animal under attack in water must constantly solve three problems at once: where the predator is, where the surface is, and how much oxygen remains. The giant otter makes all three harder. It can bite and roll, retreat and return, grab and release, then strike again from a different angle. Panic wastes oxygen. Clouded water hides direction. The surface may be only a short distance away, but in a fight that short distance can become unreachable. A failed breath is not just a missed moment, it weakens the next movement. The otter's intelligence makes the danger feel almost unfair. Giant otters are highly social mammals with strong family bonds, shared territories, communal dens, and frequent vocal communication. They maintain latrine sites along riverbanks, marking ownership with scent in a way that turns the shoreline into a map of family identity. Their lives are not random wandering. They use space, defend space, and remember space. A group hunting in familiar water understands the bends, shallows, root tangles, and escape routes better than almost anything it chases. The river is not just habitat to them, it is home ground. Even their famous throat markings tell a story of individuality. Each giant otter has a unique pale patch on the throat and chest, almost like a natural ID badge. In the brown water and green shadow of the Amazon, these markings flash when they surface, roll, or rise to look around. For human observers, the markings help identify individuals. For otters, visual recognition may also support social life inside the group. That matters because their strength is not just physical, it is family structure. A giant otter alone is already dangerous. A giant otter family is a moving system. The river around them is full of rivals. Caimans share the same waters. Anacondas move through the same flooded margins. Jaguars patrol the banks and sometimes take otters if the opportunity is right. This means the giant otter is not some cartoon champion of the river. It is a bold predator living among other bold predators, and its confidence comes with risk. Groups have been seen mobbing caimans, using numbers and aggression to drive away threats near dens or feeding areas. There is something almost shocking about it. Sleek mammals confronting armored reptiles in water that belongs to both of them. But it makes ecological sense. A den with young nearby cannot be defended politely. In the Amazon, parenting sometimes means becoming extremely unpleasant to your neighbors. The giant otter's breathing itself is part of its hunting rhythm. Like all mammals, it must return to the surface, but it can hold its breath long enough to pursue prey underwater with repeated dives. Each surfacing is quick, efficient, and controlled. The animal appears, exhales, inhales, scans, and disappears again. For prey, the contrast is brutal. The otter surfaces by choice. The victim surfaces by necessity. That difference is everything. A predator that controls when it breathes can afford to keep pressure on an animal that is struggling just to find air. The flooded forest adds more complexity. During high water, fish spread into forest interiors, feeding among submerged trunks, fallen fruit, insects, and plant matter. Giant otters follow the changing river, hunting through channels and lakes shaped by the seasonal pulse of the Amazon. During lower water, prey can become more concentrated and hunting conditions shift again. The otter's success depends on reading these changes. It must know where fish gather, where banks provide denning sites, where visibility is good enough, and where larger predators may be waiting. Its life is not only speed, it is memory, timing, cooperation, and constant negotiation with water levels. There is a surprising tenderness behind all this violence. Giant otter groups often center around a breeding pair and their offspring, with older young helping defend and sometimes care for the family territory. Pups learn the river gradually. moving from helpless dependence into the dangerous education of hunting. They must learn not just how to catch fish, but how to live in water shared with caimans, snakes, parasites, currents, and humans. Every successful adult giant otter is the result of a long training process inside a family that survives by staying together. That social world is part of the predator's power. The horror of the giant otter is not that it is evil or mindlessly savage. That would be too simple and, honestly, weaker. The real horror is that it is alive in a very focused way. It watches, reacts, communicates, adjusts, and keeps coming. In Blackwater, where reflections break and bubbles rise through the shadow, a victim does not need to be destroyed immediately. It only needs to be kept from resetting the fight. A bite interrupts movement. A roll steals direction. A second otter closes the escape. The surface is right there, shining above the struggle, but the river has become contested territory. And when the air itself becomes something that must be fought for, the giant otter is no longer just hunting prey. It is hunting the next breath. The Amazon does not only hunt from the ground. It hunts from above, from between leaves, from the underside of branches, from places where an animal's feet no longer have the comfort of earth beneath them. In the forest canopy and understory, survival is three-dimensional. A path is not a trail, but a chain of branches, vines, bromeliads, suspended roots, and narrow gaps of air. For birds, frogs, bats, lizards, and small mammals, the vertical forest offers food, shelter, nesting sites, and escape routes, but it also creates a different kind of danger. When a predator catches you in the trees, falling is a threat, climbing is difficult, and even panic has nowhere clean to go. This is the world where a tree boa becomes more than a snake. It becomes a living trap built into the architecture of the forest. Unlike the huge anaconda that belongs to the flooded channels or the heavier boa constrictor that uses roots and ground cover, the tree boa works inside a narrower, more unstable world. Its body is long, muscular, and flexible, but it is also shaped by the demands of climbing. The tail can grip like a living anchor. The body can loop over branches, hang in curves, and hold position for long periods without wasting energy. Its head stays ready at the edge of a perch, often angled toward the open space where prey must pass. To a bird moving through low branches at dusk, or a frog climbing after rain, the boa may look like nothing more than a vine, a shadow, or one more twisted line among thousands. That is the cruelty of the canopy. It is so visually crowded that danger can hide by simply matching the confusion. The tree boa's first bite is not meant to finish the prey. It is meant to steal the prey's position. Backward curving teeth grip feathers, skin, or fur, and in that instant, the animal is no longer fully in control of its own body. On the ground, prey can sometimes brace itself, push backward, or use friction to resist. In the branches, that advantage disappears fast. A small mammal may claw at bark. A bird may beat its wings violently. A frog may kick into empty air. But the branch gives only a thin line of support, and the boa already understands that line better than the victim does. The snake does not need a wide battlefield. It needs one fixed point and enough body to turn that point into a trap. Once the coil follows, the fight becomes vertical pressure. The boa wraps around the prey while also anchoring itself to the branch, so the victim is caught between two forces, the tightening body of the snake and the unforgiving shape of the tree. The prey is not only losing air, it is losing orientation. Up and down become useless ideas when the body is twisted sideways against bark, wings pinned into leaves, feet scraping for purchase, and the snake's muscles adjusting around every movement. This is what makes tree boa predation feel different. The constriction is still about breathing, circulation, and control, but the setting adds another layer of helplessness. The animal cannot simply collapse onto the ground, it is held in a suspended failure. The science behind the kill is brutally efficient. Constriction is often described as suffocation, but that word can make the process sound slower and simpler than it is. A tree boa's coils can restrict the chest, limiting the ability to inhale while also compressing blood vessels and disrupting circulation. The prey's heart is still trying to work, but the pressure around the body makes that work harder and less effective. Oxygen stops reaching tissues properly, muscles weaken, the brain loses coordination. The struggle that seemed explosive in the first seconds begins to break apart into smaller, weaker movements. In a tree where balance already depends on precision, even a slight loss of coordination is disastrous. The boa does not need to crush everything, it only needs to interrupt the systems that keep the prey functioning. Many tree boas hunt at night, when the forest changes ownership. Day birds settle into roosts, frogs begin calling from wet leaves, bats move through open corridors, and rodents climb through vines and branches searching for fruit, insects, or eggs. Darkness does not blind the snake in the same way it blinds us. Tree boas use chemical cues gathered by the tongue, vibration through contact with branches, and visual sensitivity suited to low light. Some boas also possess heat-sensitive pits that help detect warm-blooded prey, a major advantage when a bird or small mammal is hidden among leaves. The forest may look black to human eyes, but to the snake it is full of signals: warmth, scent, movement, pressure, and the faint tremor of life touching wood. The vertical habitat also shapes the prey. Birds do not choose roosts casually. Many pick thin branches that might not support heavier predators. Frogs choose leaves over water, stems over exposed bark, and calling sites that balance attraction with risk. Bats use flight to avoid most climbing hunters, but landing and roosting create moments of vulnerability. Small mammals move with quick, nervous precision because every branch is both road and escape route. The tree boa enters this world as a predator that punishes tiny miscalculations. A roost a few centimeters too close to a vine, a frog calling from the wrong leaf, a bat landing near a hidden coil. In the canopy, mistakes do not need to be large. They only need to happen within striking distance. Camouflage is central to that success. Amazon tree boas can show remarkable variation in color and pattern, from browns and grays to yellows, oranges, and more vivid forms. Emerald tree boas, with their green bodies and pale markings, can disappear beautifully among leaves, especially when resting in their coiled daytime posture. These colors are not decoration, they are ecological tools. In a rainforest, where light filters through layers of leaves and breaks into patches, a predator survives by interrupting its outline. The snake does not have to become invisible in a perfect sense. It only has to delay recognition until recognition no longer matters. Even the posture of a resting tree boa tells us something about its life. A snake looped over a branch is not merely sleeping in a convenient place. It is conserving energy, regulating exposure, and keeping its body ready for a world where movement costs risk. Reptiles depend on external heat, and in the forest canopy, temperature shifts can be subtle but important. A boa may use shade to avoid overheating, filtered light to warm itself, and sheltered branches to reduce exposure to predators. Thermoregulation in a rainforest is not always about basking dramatically in open sun. Often it is about small adjustments, higher or lower, shaded or exposed, hidden or warm. The snake's body is constantly negotiating with the forest. The tree boa is dangerous, but it is also vulnerable. Birds of prey, larger snakes, mammals and humans can threaten it. Young snakes are especially at risk, and their survival depends on staying hidden while they grow into better hunters. This is the part people often miss when they turn predators into monsters. The boa is not outside the food web. It is inside it, both hunter and potential meal. Its patience is not evil. It is how a cold-blooded predator survives in a habitat where every calorie matters and every injury can become fatal. After a successful kill, the tree boa faces the slow problem of eating. Swallowing prey whole while balanced on branches requires control. The snake must work its jaws over the prey, gradually moving the body inward while maintaining enough grip not to drop the meal or expose itself. Its flexible skull and ligaments allow it to take prey larger than its head appears capable of handling, but this process is demanding. Digestion will raise its metabolic activity sharply, and during that time the snake may become less willing to move. A successful hunt buys energy, but it also creates a temporary burden. In the Amazon, even victory has weight. The tree boa's role in the ecosystem is quiet, but important. It controls small animals that feed on fruit, insects, eggs, and other creatures, and it influences how prey use the vertical forest. Its presence makes branches more dangerous, roosts more carefully chosen, and night movement more cautious. That is how predators shape ecosystems without always being seen. They create fear, and fear changes behavior. The canopy is not just a green roof above the Amazon. It is a suspended battlefield where balance, grip, camouflage, and timing decide who survives the night. The real horror of the tree boa is not that it brings violence into the trees. The horror is that the trees were never safe to begin with. A branch can be shelter, road, hiding place, hunting platform, and trap all at once. For the animal caught there, the loss of breath is only part of the disaster. The body loses space, the feet lose certainty, the wings lose room. The world narrows to bark, muscle, pressure, and height. In the Amazon, death does not always rise from the mud or wait below the water. Sometimes it hangs quietly in the green, perfectly balanced, until the next breath passes close enough to take. The puma brings the episode back onto land, but not into safety. Away from the river's pull, away from coils, away from the black water surface, the danger becomes quieter and more exact. In the Amazon, a puma does not need to announce itself. It moves through forest edges, dry ridges, riverbank trails, broken clearings, and dense understory with the kind of silence that makes the landscape feel empty until it suddenly is not. Leaves may shift without a clear wind. A bird may stop calling for a few seconds. A small mammal may freeze without knowing why. Then the cat is there, already too close, and the fight begins at the one place the prey cannot afford to lose: the head and neck. This is not the suffocation of water where the surface is stolen. It is not the suffocation of a snake where the ribs are slowly denied space. The puma's version is direct control. A cat that reaches the neck controls direction, balance, breathing, and resistance all at once. The prey may still have legs strong enough to run, lungs desperate enough to pull air, and muscles full of panic. But those tools become less useful when the head is pinned and the throat is under pressure. In that moment, the body is no longer a coordinated animal. It is a collection of parts trying to solve a problem the predator has already simplified. The puma's power begins before contact. Its body is built for closing distance without wasting movement. The spine flexes with elastic control, the shoulders roll low, and the paws land softly enough that dry leaves may barely protest. Unlike pack hunters that can test prey over long distances, a puma depends on secrecy and timing. It must get close before the chase begins, because its real advantage is not endless pursuit. It is the short explosion. The hind legs are thick with muscle, able to launch the cat forward or upward in a sudden burst. The tail helps balance that force, working like a living counterweight as the body turns, brakes, and redirects. Every part of the animal is built around the same idea: do not waste the strike. In the Amazon, that matters because the forest is not an open arena. Roots rise like walls, vines catch feet. Fallen trunks break lines of escape, light comes in pieces, and visibility can collapse after a few meters. A puma uses that broken world with patience. It may follow game trails where deer, peccaries, pacas, agoutis, and other animals pass between feeding areas and cover. It may hunt near riverbanks, not because it owns the water like a caiman, but because prey must come there and because muddy ground records movement. Tracks, scent, disturbed leaves, and repeated pathways all matter to a predator that survives by reading opportunity before the prey realizes it has left one behind. The attack itself is brutally focused. The puma usually tries to seize from behind or from the side, using its forelimbs and claws to hold the prey while the jaws work toward the neck, throat, or skull region, depending on the size and position of the victim. Smaller prey can be killed quickly with a bite that damages the skull or spine. Larger prey may be brought down through a throat or neck hold that restricts breathing, damages blood flow, or prevents the animal from regaining control. The exact method changes with the prey, but the principle stays the same. The cat is not trying to fight every limb equally. That would be stupid, and nature does not reward stupid for long. It attacks the control center. The throat is not just a soft target. It is where vital systems crowd together in a narrow space. Airway, blood vessels, nerves, muscles that shape the movement of the head. Pressure there changes everything. Breathing can become difficult. Blood flow can be compromised. The prey's ability to orient, pull away, or coordinate escape starts to fail. This is why a neck hold is so powerful in a land predator. It does not have to destroy the entire body. It only has to interrupt the systems that allow the body to act as one piece. Panic may still fire through the muscles, but panic without direction is just wasted energy. There is a cold efficiency in that. A deer may kick hard enough to injure a predator. A peccary can slash with sharp teeth and defend itself with surprising aggression. Even smaller animals can bite, twist, and make a clean kill messy. The puma has to avoid unnecessary damage because a wounded solo hunter does not have a pack to feed it while it recovers. Every ambush is a risk calculation. That is why precision matters. The cat's goal is not drama. It is control with the least possible injury to itself. The faster the prey's head and throat are secured, the less chance there is for a hoof, tusk, or desperate twist to turn the hunt against the hunter. The puma's senses support this quiet style. Its hearing can catch small movements in cover. Its eyes are adapted for low-light hunting when the forest becomes dim and prey animals begin to move more freely. Its whiskers help judge close spaces, especially when the final seconds of the stalk bring it through leaves, branches, and shadow. Scent plays a role too, but the puma is not simply following one signal like a machine. It is combining information. where prey has walked, where cover is thick enough, where wind may carry its own scent away, where a short rush can end before the forest becomes too cluttered. The hunt is physical, but it is also tactical. This cat also carries a strange ecological identity in the Amazon because it lives in the shadow of the jaguar. The jaguar is heavier, more powerful, and more strongly associated with crushing bites and water-edge dominance. The puma survives beside it by being more flexible, often taking different prey, using different spaces, and moving with a lighter, more adaptable style. That does not make the puma weak, it makes it interesting. In ecosystems with larger competitors, survival often belongs to the predator that can adjust. The puma is one of the most widely distributed wild cats in the Americas because it can live in mountains, forests, deserts, wetlands, and human-fragmented landscapes. In the Amazon, that adaptability becomes another kind of weapon. Its kills also feed more than itself. Once a puma has eaten, what remains can become food for vultures, insects, smaller carnivores, and the invisible army of bacteria and fungi that return flesh to the forest. A hidden carcass can become a small temporary ecosystem. Beetles arrive, flies test the air, scavengers read the scent trail. Nutrients move back into soil, plants, and eventually prey again. The puma's quiet throat hold may feel like a private moment between predator and victim, but the result spreads outward. In the rainforest, nothing ends with one animal. Death is redistributed. Even the puma's need to avoid heat shapes its behavior. As a warm-blooded mammal, it generates its own body heat, but that does not mean temperature is irrelevant. In humid tropical forest, overheating is a real cost, especially for an ambush predator that may need sudden explosive movement. Hunting during cooler hours, resting in shade, and using cover are not just comfort choices. They are energy choices. A cat that wastes heat and effort badly hunts badly. The puma's silence is partly strategy and partly economy. Move only when the movement matters. Strike only when distance has already been solved. What closes this episode so well is that the puma makes suffocation feel personal without becoming exaggerated. There is no supernatural strength here, no impossible monster behavior. Just a real predator using a real weakness in the body plan of its prey. Air must pass through the throat, blood must reach the brain, the head must guide the body. Lock those places down and the rest of the animal begins to lose its argument. The legs can still kick, the lungs can still demand, the heart can still race. But the puma is holding the point where those demands must become action. So the final image is not a roaring cat in open battle. That would be the cheap version. The stronger image is quieter. A forest trail under low green light, a sudden weight from the side, claws finding grip, jaws closing exactly where resistance narrows. The prey's world shrinks, not into water, not into coils, but into the pressure of a precise hold. The Amazon does not only suffocate through rivers and snakes. Sometimes it does it on dry ground, with padded feet, steady eyes, and a predator that understands the simplest rule of all: control the neck, and the whole body starts to lose.